This presentation looks at the resources we use to generate electricity. Powering the electric grid creates a lot of carbon dioxide. We will discuss ways that will reduce our carbon footprint. This presentation was prepared by Jim Padden, with much help from Brian Thompson, who edited the work, and Joe Richard, who engineered this presentation. Narrated by Dusty Porter. Preamble. By the 1980s, scientists were reporting that the increase in atmospheric carbon dioxide correlated to the warming of the planet. Much of the increase was traced to the burning of fossil fuel used to generate electricity. The world will continue to become more electrified. The way we heat and cool our homes, power our cars, energize communication devices, all call for more electricity. Today, the primary energy source to generate electricity is fossil fuel. This presentation is an attempt to take a pragmatic look at how we can reduce our dependency on coal and natural gas. The big picture: we will discuss the electric grid, review coal and natural gas, and discuss why carbon dioxide is so important. Then, we will look at resources that don't generate carbon dioxide. Finally, we'll review our options and make some conclusions. Individual companies are linked together to form an electric power grid. Grids are designed to assure a reliable supply of power over a wide region. Individual grids are also linked together. This is a look inside the New England Grid Control Center. From here, they control the distribution of energy from hundreds of individual power plants. The grid is energized by coal, natural gas, nuclear, hydroelectric, wind, and solar. The distribution of electricity consists of three elements: the power plant, transmission lines that carry power to local substations, and the local utility that connects the substation to the meter on your home. We buy electricity in units of kilowatt hours. 1 kilowatt hour is the energy used to burn a 100-watt light bulb for 10 hours. The average cost of a kilowatt hour in the USA is 13 cents. In Florida, it averages less than 12 cents. In Michigan's Upper Peninsula, the cost is about 25 cents. Coal, natural gas, and nuclear provide 84% of our power. Renewables, such as hydro, wind, and solar, provide only about 16%. Let us take a look at how electricity is provided in North Carolina. This graph covers one 24-hour summer day. The vertical axis is for power and horizontal is in hours. Note the electricity demand curve. Electric usage is lowest around 4 a.m. and peaks around 6 p.m. Think of this graph as a bucket that must be filled using different energy resources. Wow! This is how different energy sources are used to fill the electricity demand curve. Baseload energy is provided 24/7 by coal, natural gas, nuclear, and hydro. Natural gas is also used to provide peak power. Wind and solar are used when available. The world burns 10 billion tons of coal every year. This generates 30 billion tons of carbon dioxide. China is responsible for 40% of the CO2 in our atmosphere. They are making a big effort to reduce their carbon footprint by using wind and solar. They are also building many nuclear power plants. This is coal-fired Blues, SP Creek Power Plant, located just north of Greensboro, North Carolina. It is one of the largest and most efficient coal-fired plants in the country. However, every day they burn the coal from a mile-long coal train. This plant releases 35,000 tons of carbon dioxide every day. A coal train running out of the Powder River Basin, located in the northeast corner of Wyoming. The Powder River Basin, every day 35 coal trains, each a mile long, deliver coal across the country. These coal seams are up to 100 feet thick. Fortunately, king coal is dying in the U.S. Environmental concerns, and especially the availability of natural gas, have signaled the slow death of the coal era. Natural gas is now our largest energy resource. It provides 34% of our electricity. It produces half as much carbon dioxide as coal. It is easy to transport. The gas is compressed to 3,000 pounds per square inch to use as fuel for local delivery trucks. It is also liquefied at -260 degrees Fahrenheit for use as fuel for highway trucks. We are building 6 liquid natural gas plants in order to export natural gas to Europe and Asia. Only 20 years ago, natural gas was not used to generate electricity. Up until recently, natural gas was used by industry and to heat over 60 million homes. The reason why natural gas has suddenly become our greatest source for electricity is due to hydraulic fracturing. Hydraulic fracking causes the gas-bearing rock to crack. A chemical cocktail of surfactants, corrosion inhibitors, thickeners, and special round sand is pumped into the well at high pressure. This releases the trapped gas. This is a bird's eye view of pumper trucks lined up to frack a well. Note the wellhead just right of the center. After the well is drilled, a fleet of trucks pumped the fluid down the well at 10,000 pounds per square inch. The rock cracks, releasing the trapped gas. A field of gas wells. Over 300,000 wells have been fracked. Burning coal and natural gas has caused our atmosphere to be overloaded with carbon dioxide. Carl Sagan compared our atmosphere to the thickness of the skin on an apple. Consider that the diameter of the Earth is 8,000 miles and our atmosphere is less than 18 miles thick. His message was that our blanket of air is fragile and that mankind has the ability to screw it up. Our atmosphere consists of 79% nitrogen, 20% oxygen, and 1% argon. Only a trace of other gases. The trace gas we are interested in is carbon dioxide, CO2. It is present in the atmosphere at 410 parts per million. 150 years ago, it was at 250 parts per million. Curiously, without this trace gas, plant and animal life could not exist. This is what happens to the carbon dioxide in the flue gas coming out of a power plant. 26% is absorbed by the ocean, causing ocean acidification. 28% is absorbed by plant life through our old friend photosynthesis. And 46% is dumped into the sky sewer as a greenhouse gas. Photosynthesis is the process that all green plants use to strip carbon from carbon dioxide and release oxygen back into the atmosphere. The physical structure of all trees, grasses, fields of corn are built from the carbon dioxide in our air. Up until the industrial age, nature has been able to regulate this gas. Not too much, not too little. Mankind has now tipped the balance. We face a very uncertain and unfriendly future. Okay, we have a serious problem. Namely, we are generating too much carbon dioxide. Let's take a hard-nosed, pragmatic look at solutions that don't generate CO2. One of these is hydroelectric dams. Dams provide 16% of the world's electricity. They provide 98% of Norway's electricity, so much that they export power to Denmark and the UK. Canada, Venezuela, Brazil all receive over 65% of their electricity from hydro. About 6.5% of our electricity is from hydroelectric dams. The largest energy source in the world is the Three Rivers Gorge Dam in China. It generates as much power as 10 coal-fired power plants. It is the largest cement structure in the world. Its construction displaced 1 million farmers. The dam has become a major tourist attraction. We have many power dams in this country: Grand Coulee, Hoover, Niagara, and several TVA dams. This is a picture of the Bonneville Dam about 60 miles east of Portland, Oregon. It is interesting because it supplies electricity to Los Angeles via the Pacific DC intertie. The power line is 832 miles long. Wind is the fastest growing resource for electricity. Note that Iowa receives 36% of their power from wind. In the U.S., we get 6.5% from the wind. A typical wind turbine blades are up to 200 feet long, compared to a semi-truck that is 53 feet long. A large wind turbine will generate 2 megawatts of power and cost about $3.5 million. Wind turbines are made by Vestas in Denmark, Siemens in Germany, GE in the USA, and Goldwind in China. Vestas is the largest manufacturer of wind turbines. Germany is looking to wind as a major green energy resource. They are building wind parks in the Baltic Sea to obtain 35% of their electricity by 2025. Solar receives the most public interest. Solar cells convert sunlight directly to electricity. We call these photovoltaic cells. Concentrated solar power, CSP, using mirrors is another method. Solar is growing. In the USA, we receive about 1.5% of our electricity from solar. However, many solar parks are under construction in Florida and elsewhere. This percentage will continue to increase. About 10 years ago, Germany subsidized the building of many solar parks and millions of solar panels on homes. However, only 6.5% of their electricity is from solar, much less than they had planned. Theoretically, they could power their entire grid with solar power, but only during daylight. An alternative to solar cells is concentrated solar power, CSP. This is a picture of a 1-mile diameter of mirrors aimed at the top of a 500-foot tower. Liquid carries the heat from the tower to a steam turbine to generate electricity. This installation is in Spain. We have 5 concentrated solar power plants in this country. The Ivanpah in California is the largest. Renewable energy resources. Much of the world is taking this very seriously. Others not so much. Different countries and our own states use different mixtures of hydro, wind, solar, and biomass. Note that hydro supplies 6.5% of our electricity. 70% of Brazil's and Norway receives 98%. Wind provides 6% of our electricity, Germany 14%, plans on 35% by 2025, and Iowa receives 36%. Solar provides 1.5% of our electricity, Germany 6.5%, California 10%, Florida 1%, but increasing. Wind and solar are excellent clean energy sources, but tend to be intermittent. Extra energy from renewable resources can be stored in batteries. Previously, most utilities used deep cycle lead, acid batteries. However, now lithium-ion batteries are being used in new installations. A large lithium-ion energy storage facility located near Chicago. It is used to maintain a smooth delivery of electricity to the grid. A 40-foot trailer can store 2 megawatt-hours of electrical energy. This pie chart illustrates the different energy resources we use in the USA. Natural gas will continue to displace coal. Nuclear power is at 20%, and hydro will remain at 6.5%. Wind and solar will continue to grow. However, it is unlikely that solar will ever provide more than 5 to 10% of our country's electrical power. Nuclear power, last but not the least, controversial, but an important source of electricity. It is a reliable 24/7 energy resource, does not add to global warming, does not generate carbon dioxide. For 50 years, it has supplied 20% of our electricity. We have never experienced a loss of life from a U.S. utility reactor. A typical nuclear power plant. We have 99 such reactors in this country. We have more nuclear reactors than any other country. France receives 75% of their electricity from nuclear. Sweden receives 40%. Finland, 30%. China is building many reactors. Russia, France and the USA are the major suppliers of nuclear reactors to the world market. The Navy has used nuclear power for over 50 years. Over 80 naval ships are nuclear powered. Pictured is a Trident submarine capable of firing 24 cruise missiles and the new $13 billion Gerald Ford aircraft carrier. Significant nuclear accidents. 3 Mile Island, Pennsylvania, 1979. Mechanical failure of a valve and indicator warning light confused the operators. Chernobyl disaster, Ukraine, 1986. Reactor design was flawed. Fukushima, Japan, 2011. Massive tsunami flooded the cooling pumps. Our biggest concern with nuclear is safety. We must build reactors that are designed to be inherently safe. This will require government and industry, funds, commitment, and cooperation. Our second biggest concern is waste disposal. Yucca Mountain Nuclear Waste Repository. It has been thoroughly vetted as the safest possible site for permanent storage of nuclear waste. This federally funded facility stands ready to receive nuclear waste. We need to stop on-site storage and start using this facility. Finland and Sweden have already built permanent storage facilities deep underground. Worldwide, there are 440 nuclear reactors located in 30 countries. They provide 11% of the world's electricity. We have 99 reactors that provide 20% of our electricity. Engineers and scientists agree that nuclear power must be an important source of electricity in the future. We won't be able to reduce greenhouse gases without the use of more nuclear power. Government and industry need to fund this effort. This should be a top priority. Let's summarize the problems and solutions linked to our different energy sources. No one resource is perfect, but global warming is an urgent problem seeking our best solution. Coal generates 3 times more CO2 than the weight of the coal itself. 10% of coal is ash that either goes into an ash pit or is used in road construction. Natural gas generates 1/2 as much CO2 as coal. This is not a long-term solution. Hydroelectric, limited by site availability. Wind and solar are intermittent. Nuclear, safety, and waste disposal are the major concerns. Clearly, the best solution: solve the safety and waste issues with nuclear power. Al Gore spoke of an inconvenient truth that humans' activity has contributed to global warming. Nuclear power has the best chance of slowing global warming. Call it an inevitable truth. Fossil fuels are powerful energy sources that have powered modern society. But the carbon dioxide they produce has presented us with an unsolvable problem. The problems with nuclear power are solvable. The world is doing it. We can too. The final graphs suggest some possible future scenarios. Without fossil fuel, electric companies will not be able to satisfy our demand for electricity. What would you do to keep the lights on? Time is not our friend. It is urgent that we reduce the burning of coal and natural gas. There may come a day when what we do will no longer matter. Increasing the use of nuclear power will be moving in the right direction as shown in this final graph.